Okay. So, all right. So we're in full-blown chapter 1. It's the title of the chapter is actually called Expressions, Equations, and Functions. Those are like the three major bullets we're going to hit throughout chapter 1. Now, obviously, the first part is expressions. So that's what we're going into. We need to introduce the basic premise of what algebra is, kind of what we do with it. This is kind of the first section. We're going to do this maybe the next day or two in here, just to get you kind of familiar with it again. We did a section back in the prerequisite chapter, would have been chapter 0 technically. We did a prerequisite chapter, I think it was the third section, when we introduced keywords. We did an activity where we had to know what sum of meant and difference of. That's a part of this. So now you're starting to see how everything kind of connects together, the things we talked about before. But obviously we're talking about variables. So let's go through a couple of words here. Obviously a variable in algebra. It's a symbol that we use to represent an unknown quantity, right? Something that we don't know, a value, right? So typical variables, we use x, y's, and z's. This is pretty much what most people think of when they think of algebraic expressions. The idea is that you have a variable. It could be any number that you want. It could be a decimal, whole number, fraction, whatever it is, negative. But then you take that times 3, and you add 1, that type of thing, right? That's a variable. It's an unknown. We have no idea what it is. Now, the idea is that when we do expressions like this is considered an expression. Notice, there's no equal sign. You're not solving that thing. I'm not going to suddenly just introduce an equal sign and then have you solve that thing out. That doesn't work that way. What most people always get mixed up in with Algebra 1 is they forget when you're supposed to keep going and when you can just stop. That problem is literally finished. There's nothing you can do to that problem. Now, if there was a problem like this, now we can keep going. There's rules we can do, or you can add variables together. That's what we're going to learn in this first section, or the first chapter, I should say, where you start to learn the process for how you add like terms. These are called like terms, they have the same x's. How you actually combine, there's actually property names that you need to know. They're little things you learn that you learn over an entire year of, of what I would consider junior high math. We've kind of polished it a little bit when we talk about it. But this is an example of an expression. This is also an expression, but we can simplify it. You don't solve it, you just simplify it. So if you want to know what this answer is, you move the 4x over here and add them together. That's 7 x's and a 1. That's the final answer on that. Pretty weird example. All right, you can only combine certain terms. Now, term. I've actually used that word a couple times. A term of an expression is just a piece of it, right? You're actually adding parts. These are terms. So I call them like terms. They have the same variable. If they're constants, like numbers, you can add numbers together. So maybe this problem had a 2.5. So you can add the 1 and the 2.5 together to make 3.5. Those are like terms. You can go as far as you can. I can't go any further. You don't solve. You simplify. That's the big thing, what most people forget about from junior high math, is that expressions, you simplify them. You don't solve them. Get that word out of your head. You can only go so far. All right, questions with the basic stuff that we've talked about. I think we've actually discussed, expressions before. We just never really saw the variable idea. We never used x's yet. There's certain variables that we'll avoid in Algebra 1. We avoid the letter T, looks like a plus sign. I know a multiplication sign looks like an X, but there's a difference. You can see that, especially when you put an X behind a number. It looks goofy when you put a plus sign, so you can tell it's a variable, not the multiplication of 3 times 1. Other variables I try to avoid. Try to avoid an O, looks like a 0. An I, like a capital I. Or an L, it looks like a 1 if you draw it wrong. Pretty much everything else is fair game. S kind of looks like a 5 sometimes. You get really poor penmanship. But X, Y's, and Z's are fair game. Now, if I ever use a Z, just to let you know this, if I happen to put 4Z on the board, this is how I do it. So it avoids looking like a 2. I put a tail in the middle. That's just a little thing for you guys to note. I think most textbooks do that too, so it doesn't look like a 2. All right, questions on the intro, what we're doing. Now, obviously, there's a ton of keywords. I've actually sent out a document, and probably almost a month ago, where I sent you an email where it had a Word document that we typed out in class. I think some of you actually helped type on my MacBook a bunch of keywords. That's going to be something of use. I might resend that out again, maybe in the next day or two, because it is nice to have a list in front of you in case you actually accidentally deleted that email. But it's going to be going through, expressions, the keywords. So what I'd like you to do right now, if you have your notes out, we're going to go through a couple examples today. This is pretty much what I want to do today, is intro how to use keywords into a problem. So what you're seeing here, definition of an expression. Expressions can have any type of operation, right? That's literally what an expression means in algebra. It's numbers and letters combined with basic operations. Adding, subtracting, multiplying, dividing, all that good stuff. The thing is, there's something you've probably not done yet. What I'm betting you haven't done in junior high. And it's called an exponent. An exponent is a way of putting a power on something, so it's an easy way to multiply really big numbers together. So for instance, if I wanted to multiply the idea of like 17 times 17 times 17, right? A huge number, astronomically big, right? You could just write this 17 to the third power. Because what an exponent is, this is an exponent by the way, it is a shorthand of writing when you're going to be multiplying numbers together, or variables, or whatever you have. This term right here is considered a base. So base is to a power, and the base would repeat that many times. So if you ever saw that in the book where they did something like this, 5x to the power 2. You've seen that in most textbooks. What they're actually saying here is that you have two of these x's, and they're just being multiplied together. Like that's the shorthand of what you're looking at. If you knew what x was, maybe they told you x is a 4, so I could plug 4's in there. So it's 5 times 4 times 4. Now, here's the thing. You can actually use a calculator to do these. Like my calculators, these, can actually do exponents really fast. So here's what I want. If you have a calculator like in your possession right now, take it out. If you don't, we'll grab some from the back corner. We're going to learn how to type this stuff in.
Dean, grab me one.
Here's going to see if I have any extras. I usually Anyone else need one? Did anyone else need one? Got a couple of extras. Always do. Anyone else need one? Okay. Let's see. Got one. Okay. Good. I should have it. Okay. Anyone else need one? All right. Perfect. So hopefully you have a calculator now. What I want to do is figure out how to type this in, because now, as you can tell, we get to start using calculators again. So I know a lot of you are like, thank God, yeah, we can use a calculator now. But obviously, the big thing that I want you to be comfortable with is how do you even use it, right? Because if you look at these things, there's a ton of buttons on those things, right? You can do a lot of stuff. In fact, I can do most calculus material on that calculator, most. So this can take you up through a college level class with just a $10 calculator. I've seen somebody when I was in school, I had somebody literally do their pre-calc and calc homework with one of these.
No.
A $5. They thought it was the funniest thing in the world. And they would do all their homework on one of these. So they figured out all the shortcuts they can do to type it in, even though this only has literally adding, subtracting, multiplying, and dividing. But they can do all the other stuff because they figured out shortcuts for how to type stuff in. Well, the problem is you guys aren't familiar with these, right? You've seen them, you probably own one. There's a ton of things on here. There's so many buttons, they can do anything. There's a shift key, a second key, I call it a shift key, and there's even things above those rows. And there's menus that you can go through. So the hardest part is figuring out how do you even get to stuff, what are half these buttons? That's what we kind of learned in Algebra 1. We start to learn the process for doing stuff. Now obviously this is one of the first things, right? How do you just simplify multiplying, right? Because obviously you just type in 17 times 17 times 17, and that'll give us an answer. In fact, just type that in, 17 times 17 times 17. What's the big number we're getting? It should be big.
4,913.
913. Okay, so we're getting that when you multiply 17 times 17 times 17. Okay, now here's the thing. Let's learn how to type this in faster. Because obviously that's a pain. I don't want to type in 17s, especially if this was a bigger power. I might lose track of how many times did I type that in? I mean, you could use little arrows and go back and try to count them all, but you might lose track. So there's a shortcut, there's an abbreviation for how you type this in. So here's what I like to do. Type in the number 17 in your calculator right now, like clear it out. Clear out the screen, so turn it on. Obviously, hit the little clear button. The clear button is right below the arrows to make sure nothing's previously typed in the calculator because that will affect your answer. So type in 17, and then you're gonna hit the little arrow key, this little button. It's right next to the number 7. I call it a caret. That's the correct term, it's called a caret. And what you're gonna do is you're gonna type in the exponent next. The exponent on my problem is 3, because my 17 repeated 3 times. Then hit the equal sign. What do you get? Same number, right? Does that make sense? You're learning the shortcuts for multiplying numbers really, really quickly. Now, it could have been anything. You know, I could have had 5 to the 8th power, right? You can still do this. You can still type in 5, you hit the little caret key, you type in the 8, and hopefully it can actually calculate something like that.
We learned all this in like 5th grade.
Yeah.
Mr. Heitman.
Good. So yeah, he was probably adamant about Mr. Calculator. Now, what number do we get? We get something massive, right?
13.
This number?
Oh, no, not that.
5 to the 8th. I was gonna say, it's not 4,000.
It's
That's
39,000.
390,000.
390,000.
Say it again?
390,625.
Okay, is that right?
They move.
Okay, big numbers, right? Look at this. Just to power 8, simple numbers, like those are single digit numbers. My number actually grew to 390,000 because what 5 to the 8 actually means is you have 5 8s, 8 5s multiplied together all the way across. What is that? 1, 2, 3, 4, 5, 6, 7. Is that 7 of them? And 8. There, 8 5s multiplied together. Well, these make 25, this makes 625, and you just keep going until you get to 390,000. Big numbers, right? Now, obviously, you've seen this before. Hopefully, this is starting to make sense how you type stuff in. It's one of those things like, it is a shortcut. It makes your life so much easier knowing how to type stuff in correctly, the short ways to do it. But, here's the problem. Have you even thought about what these numbers represent? Like, what is 5 to the 8th power, right? Obviously, we know it's 390,000. But have we ever thought about if you were to put 10 to a power? So, think about this. If I went 10 to the 4th power, 10 to the 4th power, what do we get?
10,000.
10,000. Here's the easiest thing to do. If you have a 10 and you're putting it to a power, the power is how many zeros you have. So on a 10 and it has 4 on it, there's literally 4 zeros on that answer. It's a 1 with 4 zeros. If it was 10 to the 6, yeah, it's literally 6 zeros written across, so it's a million.
Good day.
Now, right, shortcuts. But here's the thing. Think about this in terms of distance, right? If you were at 10 to the 1, that's 1 0, that's just the number 10. Imagine that's 10 meters, right? 10 meters. 10 meters is a lot. In fact, Mason, can you go grab one of my my yardsticks or meter sticks in the back? One that goes up to 39 on it, 39 on one side where it has inches. Does that one go up to 39 or is that 36? 39, there it is, there's a meter stick. Okay, boom. All right. What you're looking at here, that's a meter stick, right? If I had 10 to the first in meters, you'd have 10 of these. Okay, 10. There's 1, 2, 3. I'm almost halfway across the room. 4. It's about 6 across. I'd have to be almost into my back room back here with 10 of those. Now, if you went 10 to the second, now you're looking at 100, right? That's almost the length of the building. Okay, and then you keep going, right? It's not yards. This isn't a yardstick. Yardstick is about 3 inches shorter than that. It's about yay big. There's a yardstick, as opposed to a meter, which is just a little bit longer. It's a metric system versus U.S. customary. But what most people never think about is like, in terms of distance, what that number actually means. 10 to the 6, if you were at 10 to the 6 and you were at a distance, let's say let's say we're going up in the air, instead of like long-wise, let's go like up in the air, 10 to the 6. You'd be at a point where you could have, if you were like taking a picture, you'd have the entire Earth in your view. Like you would be in space where the Earth could actually fit in one camera shot on your phone. Because at 10 to the 5th, you'd be too close, the phone wouldn't be able to back up far enough to see the entire Earth. You'd have a pretty good glimpse of like the United States and South America. But at 10 to the 6th, the whole Earth is in view. At like 10 to the 7th, you're past the moon and you're almost to Mars. Like in terms of distances, in terms of meters. And most people don't even think of that. If you kept going and you went like 10 to the 23rd, you're at the border of what our known universe is. Where we can't see past that point because our limit on our actual satellites can't view light past that point.
Wow.
So that's our known visible like
So that's
universe.
Toy Story.
So
I've never watched Toy Story.
You've never seen Toy Story?
Before.
yeah.
You gotta watch every Toy Story.
This is us.
So back
No,
that's
it's
what
not.
I was saying.
You don't like This Is Us?
Dark
Never
is
seen
gonna be
Oh, it's
I
a
watched
good
TV.
show. Blackish is the funniest
I didn't
thing
have to be
ever.
at home.
Well, you watched it.
Yeah, pretty much. But I don't really do anything with that.
What do you do?
Fortnite.
No, don't even do that. Half the time I'm working. I'm here almost all day. Or I'm playing with my son half the time. Alright, so I'll let that restart. Alright, but what most people don't think of is like what that means in terms of distances. It's incredible. You would have at 10 to the 23rd, you're at such a far distance that you can literally see almost every single galaxy in view that we've previously like spotted in the sky, right? Galaxies have billions of stars, right? I think at like 10 to the 13, you've exited our Milky Way galaxy. And then you keep going and you see other local galaxies at that point. It's like one of those things like unless you see that number, most people don't even like comprehend that. Like what that is in terms of distance. In terms of numbers, right? In terms of like actual like raw numbers. Let's say you had 10 to the 8th power, right? 10 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. All right, there's 8 zeros. This is $100 million. There's a couple like Powerball jackpots that you could do that, right? You could have won 100 million. I think it got up to like 600 million at one point.
What?
In terms of like numbers, like that number, I think when I did a calculation, that is that's like, imagine you had a Microsoft Word document and you typed in 10,000s into it constantly, all the way across the row, and you put like a 1 space between them, and you just typed them all the way across 10,000, 10,000, and you just copy and pasted, and you kept going, right? You'd have 23 pages of these to get to like $100 million. 23 pages of just 10,000s pasted across the screen forever, right? Just imagine 23 pages, and these go line for line all the way across until you can't go anymore, all the way down like 1-inch margins on a piece of paper, 23 pages of it. If you just spent $10,000, you wouldn't even see it. If I gave you 23 pages and I erased one of them, it would be hard to spot. Okay? But you could, in the Powerball, there was a potential where you could have won 600 million. 6 times that number, 6 times 23. Now, that doesn't seem like a lot until you put it in terms of like actual like numbers. Because 23 pages of that. Let me give you an idea. Because most people don't think of like numbers in such a way that I do. All right, let me see if I can. Okay, so in terms of numbers, right? This is 23 pages of these 10,000s repeated over and over and over. My paycheck was like half the first row for an entire year. An entire year's salary for me was not even the first row. It was like half a row. And that's over like 15 years of teaching. My salary is the first row. They won 23 pages of multiple rows of that in one go. In fact, here's the worst part. Think about this.
You lose so much in taxes.
You would, you'd lose about half, but you'd still be at 12 pages worth of those. Okay? Here's the worst part. Apple computers. Think about this in terms of like computer systems, right? Apple computers, they make the iPhones and iPods and MacBooks and whatever. They have in cash, in hand, where they can just buy stuff, $500 billion in cash just sitting in a bank.
Gee.
Billion with a B. 500, right? This is million.
What the mean?
Billions are another couple numbers after that. In cash. So when they, what was it, 2010, they bought Beats headphones, right? Apple bought them. Most people don't know that, right? Apple owns Beats, right? They bought them for $3 billion. It was nothing to them. Like, you hear that number, like $3 billion, God, that's a lot of money. It was pocket change. And they made that money back in 1 month. Right? Apple is about to announce on October 30th, they're about to announce their quarterly earnings for the year, right? Every 3 months, they announce how much money they make and how many products they've sold. It helps investors feel comfortable with Apple, right? Because people have stocks, they don't want to sell them. They're probably going to announce the highest number of iPhones they've probably ever sold. And they're going to announce that they probably made, and this is what I'm predicting, $63 billion profit. Last quarter was 72 billion. Billion. In 3 months they make $1 billion.
Well, they lose money.
They don't. Apple doesn't lose money. So it just depends on the cycles when people buy them. They haven't reported a loss in like 20 years.
Gee.
How much does Bill Gates make like a second?
Bill Gates doesn't work for anyone anymore, but he's worth like $60 billion or something like that just
Didn't
himself.
he used to make like?
It was astronomical money. It was like a second was like, I think it was like almost $100,000 a second or something like that.
Who do you work for?
Microsoft, he owned Microsoft.
Oh.
So, but yeah, this is what Apple's about to report, and that's a 3 months earning. That just adds their $500 billion. So, in terms of money, like most people don't think of this, with that amount of money, you could buy every NFL team, all of them, and own them, with $63 billion. With the cash they have in hand, the 500, you could buy every MLB team, baseball, every NBA team, every football team, every movie studio, and every record producer, and still have cash to keep going. Every single one of them.
You make a bunch of money from all the ones you
They would make all their money back in literally a couple seconds from
Why
owning
don't they
them.
do that then?
They could have. They can't because the federal government won't allow them to. It's called a monopoly. They can't be a monopoly. They can't own more than what they produce, right? So they're being researched for that right now. Like their app store is considered a monopoly because they pretty much own the app store market. So they can't own that. They have to break it up a little bit. But yeah, it's like crazy. When you think of terms of numbers, most people don't even think of that. They could buy everything. They could, if you took all the billionaires in the United States, you could pay off the national debt. National debt's like $17 trillion what we owe to other countries. You could pay off the national debt with just the billionaires. They could combine all their numbers and pay it all off. It's crazy the numbers, right? When you start thinking about in terms of like actual like documents, what that means in terms of numbers, right? Yeah, it's nuts, like the terms of but you're starting to see like the first sign of it. Like some people like don't even think of this, they just see 5 to 8, right, it's 5 to the 8. What that means in terms of numbers is huge, right? 5 to the 8th power, that's a big number in terms of like money or distance, right? All right, if that was in miles, 5 to the 8th, in terms of miles, 390, 625. In terms of miles, you could go around the Earth 15 times with that number. 15 times around the Earth, the entire Earth, all the way around the equator. 15 times going around the world. It doesn't look like a big number until you start putting it in terms of like realistic things, right? All right. it was one of those things I wanted to show you that because, you know, I can show you how to type stuff in, but until you actually like soak it in a little bit, like what these numbers actually mean, it's not that impressive. But now, here's the idea. Let's go to some examples. So, all right. So, these are examples I'd like you to just try to type in your calculator, or if you just know the answer, just kind of think about it here for a second. 5 to the second power. What does that mean? 5 times 5, which is 25. Okay. A to the third. Yeah, A times A times A. If we knew what A was, we could take A times A times A. -4 to the fourth.
-4 times 4.
Yeah, you have 4 -4s, right? Now, will the answer be positive or negative? Let me use the dot for multiplying. The answer would be positive.
Yeah.
Because every 2 numbers, they would cancel out. Every 2 numbers, they would cancel out. It's a positive number. It's 16 times 16, which is 256.
If it was 5, it would be negative.
Yeah, if there was 5 4s, you'd have a negative number. Right? 60, or what is that? 256 times another 4. Okay? Which is 1024 or something like that. All right. Now, here's the difference. This is something that a lot of people don't know. I want you to type this in. Go to this one up here, type this in your calculator right now. Parenthesis, -4, close the parenthesis, hit the little caret key, and then type in the 4. So again, parenthesis, hit the negative sign's right beside the decimal point. Close the parenthesis, hit the little caret, and hit 4, and hit equals.
256.
Say again? 256. Okay.
That makes sense.
256, right? It was the number I just said a little bit ago. Okay? Now, go to the bottom one, this one, type in the negative sign, type in 4, hit the little caret key, and type in 4 again.
Negative 200.
Oh, okay, so here we go.
I'll go to our negative.
Okay, 'cause I just told you a little bit ago, you have 4 for power, cancel out negative signs. There's a difference between these two, how you type them. Without the parenthesis on it, here's what your calculator thought you were doing. It thought you were doing 4 to the 4th power, and then it wanted you to put a negative sign in front of it. That's what it thought you were typing. With the parenthesis, when you had this one up here, it thought you were taking -4 times -4 times -4. It thought you were doing this. But this bottom one didn't. It's not your fault, it's the way that the calculator's programmed, because it thought you were going 4 4s and then put a negative sign in front of it. When you have the parenthesis, that makes the difference. You do need to know that concept, if it's positive or negative, because the parenthesis makes a huge difference. All right, I thought I better include that. Some people always get that wrong when you get to like ACTs and you get to like the standardized maps tests and whatever we take. They always get those wrong. They always forget what the calculator is giving them. All right, next, keywords. Words we've talked about before. Okay, I just put a small list together here. Sum of, difference of or subtraction, multiplication is product, division is quotient. Now I only included a small list. We came up with crazy lists about a month ago, like where we had like everything you could possibly think of. With addition, sum of, more than, plus, added to, increased by, total, like there was a ton of words we used. With subtraction, it's difference of, but decreased by, subtracted from, less than, minus, we had just a bunch of different ones. Multiplication, I had these. The new one here that I did not include on that list, I'll try to add it before I send it out again. The word of, just in general, means to multiply. Just in general. The word of means you're multiplying. And then quotient of is division, or half, or you're cutting something in half or a third. All right, so here's what we're going to be doing the next couple days in here, like maybe Friday and Monday. Can we actually write down the formula that this sentence would represent? Right, a number, n, they give you the letter, the number n, more than 6. So what does the keyword more than mean? Plus. So I'm going a number more than 6. That's the answer. That's an expression. I want us to get used to those keywords. So tomorrow, here's what I want. Tomorrow, for sure, bring your Chromebook tomorrow, if you have it, and I want you to open up the document that I'll email to you when we start class tomorrow. That document